Patty Simpson with Simpson Math. In this video, we're going to learn about classical or theoretical probability. We're going to look at a few random walk problems. So here we have Christopher Walken, and he's in a hotel a lot. And so when he's trying to exercise in the hotel, what he does is he goes to the stairwell and he just randomly picks some stair to start on. In this case, he started at the second step. Then he just walks up and down steps randomly until he hits either the well or the landing. And the minute he reaches the landing or he reaches the well, he's done with his exercise for the day or for that exercise session. And somebody watched him at some point and found out that the probability that he goes up is 30%. It's always a 30% chance that he's going to take a step up. But it's a 70% chance that he's going to go down with his step. And that just is always true when he's walking up and down randomly. So I want to know, for this particular problem, what is the probability that he makes it to the well in exactly 4 steps? So the first thing we do when we're working these classical or theoretical problems is we put the problem into words. Before you start using numbers, the first thing you need to do is think about, what does the scenario look like? How can I put this into words? So Christopher Walken here, in order for him to make it to the well in 4 steps, what he would have to do is take a step down, and take another step down, and take another step down, and take another step down. So he would have to go down and down and down and down to get to the well in 4 steps. So I'm just going to write down those words first. So down and down and down and down. And really, when we're solving probability problems, the first thing we should do is just write down the words that go along. Like, how could I do this situation? Then putting the probability with it is nice and easy. So now that I have my words written down, now I can add the probabilities and find that probability. So the probability that he goes down is 70% every time. So I'm going to write 70%. I like to write my percents as fractions. So I'm going to write that 70% as 70 over 100. When dealing with probability, when I see the word and, I think of multiplication. So I'm going to multiply there. So then 70% that he goes down again, and another 70% that he goes down again, and 70% that he goes down that last time. Now, since there's no addition in here, I'm just multiplying, I'm going to go ahead and simplify before I multiply, just to make it easier numbers there. I'm going to divide the top and the bottom by 10. You know, I'm dividing by a fancy 1, 10 over 10. And so each one of those is just equal to 7/10. So I've got 7/10 times 7/10 times 7/10 times 7/10. Which on bottom, that's nice and easy to multiply by. You've got 10 times 10 times 10 times 10. I'm going to end up with 4 zeros and a 1 out front, 10,000 there. And then on top, I'm multiplying 7 times 7, which gives me 49, times another 7 times 7 is 49. So 49 times 49 is 2,401. So the probability that Christopher Walken goes down and gets to the well in just 4 steps is 2,401 out of 10,000 times. So let's just change this up just a little bit. And instead of going to the well in 4 steps, let's now make this the landing in 4 steps. So, you know, what is the probability that he then gets to the landing in 4 steps? Well, now our situation has changed. We're no longer just going to go down and down and down. Instead, we have to, again, put it into words. Decide how can he make it to the landing in just 4 steps. So let's look at it. Well, he could go up, but if he goes up again, he's at the landing and he's done. So he just made it to the landing in 2 steps. We want him to get 4 steps in this exercise. So going to the landing in 2 steps doesn't cut it. So instead, if he goes up, then in order to get to 4 steps, he'd have to go back down and then back up and back up again. So to get the 4 steps in, he would have to go up and down and up and up. Let me write those words down. So he goes up and down and up and up. Now, is that the only way he can make it to the landing? Let's see. What if he went down first? Can he still make it to the landing in 4 steps total? Well, let's see if he can. If he goes down, then goes up and up and up, sure enough, that gives him 4 as well. So there are 2 different ways that he can make it to the landing. Up and down and up is one way. Or another way he could do it is to go down and up and up and up. If he tried to go down twice though, down and up, oh, he doesn't make it to the well in time. So there are 2 different possible ways for him to get to the landing in 4 steps. Now that we've found the different ways and we've thought about with words how we can come up with the ways for him to get to the landing in 4 steps, now we can add the probabilities in. I want to encourage you to first write it down in words and then add the probabilities to it afterwards. So now when we're looking at the probability he goes up, well, it's a 30% chance that it goes up. I'm going to go ahead and reduce that 30 out of 100 and just make it 3/10. You know, 30% is the same as 30 out of 100 or 3/10. And when I'm doing probability, makes me think multiply. Down is 70%. We just saw in that last problem that 70% is the same as 7/10. And makes me multiply. Up is 3/10 and up is 3/10. This or, when I'm thinking about probability, or reminds me to add and then look for any overlap. In this case, going up and down have no overlap, so I don't have to worry about the overlap part. So I'm just adding. Then I'm going to look for the probability of each piece again. So down is 7/10, and up is 3/10, and up is 3/10, and up is 3/10. So by having it written down in words, then it just helps me to realize that here I'm supposed to be adding and there I'm supposed to be multiplying. It makes it easy for me to find those different probabilities. Now it's just a simple task of doing some simple arithmetic. I've got on the bottom here 4 zeros, or 10,000. And on top I've got 21 times 9, which is 189. Here, notice that this is the same as that. The numbers on top are the same. They're in a different order, but they're the same numbers. So I end up with that same 10,000 and that same 189. So I'm just adding that twice. So I could add it together twice and say that is, that's equal to, let's see, 378 over 10,000, and then reduce from there. Or another way to think of this is just to do 2 times that 189 over 10,000. And then I can simplify ahead of time. So notice this 2 goes into that 10,000 5,000 times. So if I were to reduce this, I would get the same thing. I'd get 189 over 5,000. You know, divide the top by 2 and divide the bottom by 2, so that I end up with that same thing. So the chance that he ends up at the landing in 4 steps is 189 out of 5,000 times. So if I wanted to know what's the probability that his exercise would be done in 4 steps, well, his exercise to be done in 4 steps, he would have to make it to the landing or to the well. So what's the probability he makes it to the landing or the well in 4 steps? Well, this is the probability he makes it to the landing. And we found a second ago that the probability that he makes it to the well is, so to the well, that probability was equal to 2,401 over 10,000. So if I wanted to find out the probability he ends his exercise in 4 steps, I'd have to find this probability of landing or well. So I would take and add those together. Now I need a common denominator when I'm adding. So landing plus well would give me the probability that his exercise is done in just 4 steps. So there's our landing plus our well. So the probability his exercise is done in just 4 steps. You keep your denominator when you're adding fractions, and then you just add your numerators. So there's the probability that his exercise is done, exercise finished in 4 steps. Okay, let's change it up just a little bit. What about if he wants to work out for 6 steps and he wants to make it to the well in 6 steps? Then how could he make it to the well, in 6 steps? Again, the best way to do this is to decide first in words how we're going to make it to the well in 6 steps. So let's do a little figuring here. So if he's going to make it to the well in 6 steps, if I go 1, down, and down, and down, and if he goes down again, he's done. So we didn't make it in 6, we only made it in 4. So once he's made it down 3 steps, he's got to go back up before he can go down again. So he goes up 1, and then he can go down, and there he is in the well in 6 steps. So one way to do it is to go down, and down, and down, and up, and down, and down. I'm going to use symbols this time to tell me that down, but I'm going to write it, these are my words here. So down, and down, and down, and then he has to go back up, and down, and down. So let's make sure that's 6 steps. 1, 2, 3, 4, 5, 6. Now, is that the only way he can make it? Well, what about if he went down, and then back up, and down, and down, and down? That would give me 6 steps. So that's another way to do it. So, or he could go down and down, just go down twice this time, 1, 2, and then go back up, and then down, 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 and down, and down. And again, I'm saying that and in between each one of those, so I'm going to write the word and in between each one of those. Is that all of the ways? Well, what about if he just goes down 1 spot? Let's try just going down once. So, or what if he just goes down once and then goes back up and then goes down and down and down and down? Oh, that's 6 steps also. So that's another way that he could make it to the well in 6 steps. Is that all of them? Let's try, what if he goes up first? Let's see if he goes up first, can he make it down? So up and down and down and down, and down, and down. Oh, there's another way that he can do it in 6 steps. Make it down to the well. What about if he goes up 2 steps? Let's try that. Well, 1, 2, oh, he's at the landing. So that doesn't work either. So these are all the different ways, or this way, are all the different ways that he can make it to the well in 6 steps. Once you have it in words, then finding the probability is a lot easier. But I really want you first to think about it in words before you try to put down the numbers. Now that we have the words though, now we just add the numbers. So you got 7/10 times 7/10 times 7/10 times 3/10 times 7/10 times 7/10. And each one of these ands just reminds me that with probability, I'm thinking multiplication. Whereas the ors remind me that I'm gonna add. So, and here I have the same thing, 7/10, 7/10, 3/10, 7/10, 7/10, 7/10. That or tells me to add 7/10 times 3/10 times 7/10 times 7/10 times 7/10 times 7/10. I'm going to add, and then I have 3/10 times 7/10 times 7/10 times 7/10 times 7/10 times 7/10. Now what I want you to notice is on each one of these on top, I have 1, 2, 3, 4, 5 sevens and a 3 on every one of them. And when I'm multiplying, that order that they're in, multiplication is commutative, so the order doesn't really matter there. It's going to end up with the same number. So when I multiply every one of these, I'm going to end up with that same number each time. The 50, this is going to be 50,421 on top. And on bottom, when I multiply, I end up with 1, 2, 3, 4, 5, 6 zeros. So for each one of these, the chance that he makes it down to the well in 6 steps this way is 50,421. And this, when I multiply this out, it's going to be the same thing. And when I multiply this one out, it's the same thing. But I need to add them all together. Well, instead of multiplying them each one and adding them together, what I can do is just say, hey, I've got 4 of these. And I can just multiply, instead of adding this 4 times and then simplifying, I can just multiply all 4, one of them by 4. So I could add them and then simplify, or I could just take this and multiply by 4, because that's the same thing as adding them over and over again. So let's just do that. Let's just multiply by 4. Well, if we do that, 4 goes into a million, 2,5,0,0,0 times, so 25,000 times. Oh, I think I left off a 0. Let's see, it goes into 10 2 times with 2 left over. It goes into 25 times, a 0, and then 3 zeros back there. So 250,000. So the probability that he makes it to the well in 6 steps, all those different ways are possible. The probability is 50,421 over 250,000 times. So when you are dealing with theoretical or classical probability, the idea is first you want to think about it in words. What are the different ways that I can get to that point? Write it down using those conjunctions of and or to help you out so that when you get ready to put down the probability, it just makes it that much easier for you. Thanks for watching.